Ladies and gentlemen, my name is Miskiv-Pavlik and I am a PhD candidate at Technical University of Kosice at Faculty of Manufacturing Technologies with seat in Prešov. I am pleased and honored to participate once again in this online conference. I would like to introduce you the article Application of Vernier Measurement System as a Smart Element in Physics Education Process. This article was prepared for this conference in cooperation with Associate Professor Oleksakova, Professor Jurko, and my colleague Mr. Kascak. This presentation consists of 5 chapters: the introduction, in which we approach the aim of the article, the application of new Vernier measurement and educational system, and their implementation in the process of education in physics at the Faculty of Manufacturing Technologies. The second part consists of the description of Vernier's DTS and GDX measurement system that have been used in the physics education. The third and the fourth chapter deal with the description of the statistical processing of the data obtained from the experiment, in which first-year bachelor students completed an entry questionnaire at the beginning of the semester and an output questionnaire at the end of the semester to demonstrate positive effects of application of the Vernier measuring and education support system. The presented article focused on the analysis and statistical evaluation of the educational process in which modern information technologies were implemented into the educational process of physics and exercises in physics courses intended for full-time and external students in the first year of the bachelor studies at the Technical University of Kosice at the Faculty of Manufacturing Technologies with a seat in Prešov. The main thesis is the renewal of the educational process of physics by using the Vernier measuring systems, which is a complex solution for the school laboratory and enables practical teaching with the latest computer and mobile communication devices. Based on students' results from the questionnaires, the faculty plans to purchase more Vernier measurement systems, better integrate students into the educational process of physics. Based on students' responses, the teacher can focus on areas that the students are having the most difficult with. The output questionnaire at the end of the semester was intended to show whether the innovation of the laboratory with the new measuring equipment increases the interest in the physics studies, strengthens the knowledge of the physics, and contributes to the improvement of physics teaching at the Faculty of Manufacturing Technologies. The education process of physics was innovated by the mentioned Vernier measurement system, which provides a complete solution for school laboratories and allows a practical teaching with the latest computer and mobile communication devices. The main reason for application of this measuring system is often the problem that students do not see a practical significance and application of physics in real life, and this needs to be changed. It should not be forgotten that organizing an experimental lesson for students requires proper training by the teacher as well. Do not mention the time intensity, material equipment of the school, insufficient number of tools, and poor working environment. Nowadays, engineering practice requires highly skilled professionals who have a comprehensive understanding of the state of modern engineering and can work with the latest technologies. That is the reason why a modern applied physics laboratory has been set up at the Laboratory of Applied Physics in this article, which use the latest information and education technologies as well as Vernier measurement systems. The first of the used measurement system is a dynamic wheelchair DTS with a wireless connection to study the motion, flexible collisions of the carriages and the laws of the conservation and momentum and energy. Using a force sensor and a set of buffers, is possible to study the relationship between momentum and impulse. Next applied device is a GDX measurement system to study damping force and its relationship with angular velocity, weight, and turning radius. The rotating arm with two moving trolleys and the cable mechanism is mounted on a stable frame. We can also study rotational dynamics by calculating the forces necessary to keep matter in a circular motion, or Newton's laws involving torque and rotational motion. This system is characterized by very simple and intuitive operation and a wide range of different measurement sensors and a reliable software solution. The result of laboratory measurements can be evaluated not only on computers but also on tablets or smartphones. The experimental part of this article consists in the statistical processing of the students' results in the first year of bachelor study at the beginning of the semester with the Vernier measurement system and after its application in the educational process. The statistical analysis itself consisted of processing two questionnaires. The entry questionnaire was completed at the beginning of the semester when the student had no experiments in using the Vernier measurement system and only had knowledge from the high school. Compared to the entry questionnaire, a second output questionnaire was also completed, after which we evaluated students' score results. Based on the students' responses to each question in the questionnaire, the teacher can then identify the area with which the students have the greatest problem and exploit the problem using individual Vernier measurement systems. The questionnaires consisted of 6 questions from different areas of elementary physics. A total of 87 students, male and female students, participated in this experiment. The first part of the descriptive statistic was to create a table in which we determined the absolute impedance. In the next column, we reported the relative impedance, cumulative impedance, and the cumulative relative impedance. These students were divided by the type of the high school they graduated from, namely the gymnasium type of school, vocational school, or other type of the educational institution. As a first step in the statistical analysis, we started with a comparison of the individual test results. The results of the input and output tests were divided in a simple breakdown according to the number of correct answers of each student from 1 to 6, representing the value of the x. Analysis of the table showed that the highest number of responses ranged from 5 to 49 students, representing 56% of the total number of responses. Overall, 68% of the students had 5 correct answers and only 32% of the students scored full marks. Compared to the entry test from a table, there was an improvement in the students' overall score when the highest number of correct responses was 6, with the 49 students representing 56% of the total responses, which is a 24% improvement compared to the entry questionnaire. The percentage of the students who gave up to 5 correct answers dropped to 44%, which is a 20% less than the entrance questionnaire. One of the negative phenomena that occurred in the output questionnaire was also the occurrence of the lower interval responses categories such as 1, 2, or 3 responses, which did not occur in the entrance test, but their number has very little impact on the total number of responses. After division the respondents according to a high school they graduated, the first group was the graduates of vocational type of high schools. The sample included 55 respondents who were not yet divided according to a number of years of physics completed. It can be seen from figure that the biggest problem for the students in the entry questionnaire was question 5, which only 63% of the respondents answered correctly, and they performed best in the question 1 when they achieved a success rate of 100%. Compared to the entry questionnaire, there was an overall improvement in student score when using the Vernier educational measurement system from 86% to 88%. The second group of respondents were students who graduated from a gymnasium type of the high school. The number of respondents this time was 13. In the case of an entry questionnaire of the students who graduate from a gymnasium secondary school, we can see from a figure that the lowest percentage of a successful answer was for question 6 and 4, only 61% and 69%. Overall, the average percentage pass rate of the students from an entrance questionnaire was 85.9%. Comparing the results of the entry and output questionnaire of the gymnasium student sample, we can see an improvement in the question 2, 4, and 6, and a deterioration in the 3 and 5. The overall success rate was an average level of 91%, which corresponds to an improvement of 5%. For this category of students from another type of educational institution, the table shows that these samples scored the lowest or worst results after application of Vernier system. Students' average percentage success was 87.7 on the entry questionnaire and only 85.9% on output questionnaire. Students had most problem on question 4, and the highest number of correct answers were on a question 1. The distance learning factor due to COVID-19 pandemic must also be factored into the questionnaire results, which was reflected in some of the poorer responses on the output questionnaire, such as question 1 and 6. In the overall comparison of the results from the entry and output questionnaire, it can be seen that there was an improvement in the results, which is confirmed by the average value percentage of the questionnaire results, with the entry questionnaire showing 86.8% and the output questionnaire showing an improvement 87.9%. The highest improvement occurred in the question 4, where there was an improvement from 65.2% to 87.3%. After dividing the respondents by completed years of the physics in high school, we can see that there was an improvement in score in almost every category. For students who had only 1 year of physics, mostly students from other schools, the improvement in scores ranged from 87% to 89%. In the 2-year category, the improvement was from 84.7% to 85.4%, mostly students from vocational type of high school. The third category was the students with the 3 finished years of physics in high school. In this single category, the results deteriorate from 83.3% to 80.9%, with the largest number of students being gymnasists. The final category was the 3+ years completed physics, where the improvement was from 88.2% to 90.2%. The composition of the students was mainly from a gymnasium type of school, and the minority proportion was from a vocational school. Finally, the groups and Dixon square outlier detection test was performed, in which we determined the distance between the lowest and highest measurement responses to determine if any of responses were not too demanding. Using these methods, we can determine if the questionnaire results contain a value that proves to be an anomaly compared to other ones. Through such analysis, more challenging questions can be defined based on the number of correct answers in a questionnaire. In the first step, we rank the samples by size in both questionnaires into the non-decreasing sequence. The measurement values for the input questionnaires were 57, 72, 73, 81, 85, and for the output questionnaire 74, 75, 76, 78, and 81 correct answers. The first questionnaire is to determine whether the values of 57 and 85 are outliers. The test results showed that none of the values were too far off, which was supported by the box plot, so all the questions were appropriate. The output questionnaire results at the end of the semester confirmed to us that the innovation of the laboratory with the given measurement system increased the interest in the study of physics, strengthened knowledge of the physics, and contribute to the improvement of the education process of physics at the Faculty of Manufacturing Technologies. In further research on the application of Vernier measurement systems, we would like to show the advantages of using this system not only for physics classes, but also for mechanics, statistics education process, and more. In the end, I would like to thank you for your attention and wish you all the best.